Good afternoon, children. Now today we'll talk about combination of capacitors. We have already talked about a capacitor. It is a device to store electric charge. We have also talked about how the capacitance of a parallel plate capacitor can be mathematically calculated. Then we have also talked about if in case we put some other medium than air between the plates of the capacitor, then how the capacitance will change. Now we'll see if the capacitors are combined in different manner, that is in series or in parallel, what will be their equivalent capacitance. You might remember that in class 10th we have done combination of resistors, and there you saw that when resistors are combined in series, like for example you have got three resistors R1, R2 and R3, and if they are combined in series, then the equivalent resistance came out to be R is equals to R1 plus R2 and R3. And if they were combined in parallel, then in that case the equivalent resistor was found out by this expression. 1 upon R is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. This we'll be doing this year also, but now it is in unit second, that is current electricity. So this you have to do as you have done in class 10. Whatever we have done in class 10th in current, that has to be repeated. Apart from that, we'll have some new topics. Now this was just to recall. Now it will be done in a similar manner, but now you will see that the results will come out to be exactly opposite. That is, when we combine capacitor in series, then you will get this mathematical expression, and when we combine them in parallel, you will get this expression. And therefore, while doing the questions of capacitor, you have to be very, very careful. Even after remembering, many students make mistake. So first, capacitors in series. So let us consider three capacitors, say C1, C2 and C3 connected in series across, say, a potential difference V. So capacitance is say C1, C2 and C3. This is the series combination. Now you have to remember one thing, that in series combination here, charge will remain same. Charge on each capacitor will be same. When we talk about series combination of resistors, it is the current which remains same. Here, since capacitor stores charge, so charge on each capacitor is going to remain same. So one of the plates will be charged positive, another negative. Now whatever potential is being applied here will drop across each circuit element, and here we have got three capacitors. So a part of V will drop over here, a part of it across here, and a part of it across here. That is, the potential across each capacitor will be different depending upon the value of capacitance. If suppose the value of capacitance is same, all the three capacitors are same, therefore they will be equally divided. So now from this, total V must be equal to V1 plus V2 plus V3. And now we can write down the value of V1. For a capacitor, Q is equals to CV, or V is equals to Q upon C. This we have already done. So here now V1 will be equal to Q upon C1. V2 will be Q2 upon Q upon C2 and Q upon C3. Now suppose in place of these three capacitor, I want to only keep one capacitor. Say capacitor of capacitance, say C. Then all of the potential difference will fall or drop across capacitor C. Only the charge certainly is going to remain Q only, because in series the charge is going to remain the same. So in place of V I can write down Q upon C if C is the only capacitor in the circuit. This is going to give me 1 upon C is equals to 1 upon C2, 1 upon C1 plus 1 upon C2 plus 1 upon C3. This is my series combination. You can see here in series combination we were getting this answer here, and for parallel here. But now see here for series we are getting 1 upon C is equals to 1 upon C1 plus 1 upon C2 plus 1 upon C3. I am again reminding you that in a series combination, charge stored in each capacitor will remain same. Potential will be different. Now we'll take the case of parallel combination. Now for parallel combination, we'll again take 3 resistors in parallel. So this is the second case, capacitors in parallel. So let now 3 capacitors, say C1, C2 and C3 are connected in parallel. C1, C2, C3, they are connected across a potential difference, say V. Now the charges stored by the capacitors will be different. If the total charge supplied is say Q, then out of that, say Q1 is stored here, Q2 and Q3. They have got different options depending upon the capacity of the capacitor. Different charges will get stored because they have got different options over here. Like in parallel combination, current was different depending upon the value of resistance. Less resistance, more current. But now you can see here the potential is going to remain same. So in resistors we talk about current, in capacitors we talk about the charges stored. Now from here you can see the V is same. What is different? Q. So the total charge which is being supplied to these capacitors, say it is Q, must be equal to Q1 plus Q2 plus Q3. And as we know Q is equals to CV, that means Q1 must be equal to C1V plus C2V plus C3V. As in parallel combination, potential will remain same across each capacitor. You can see it physically also. Potential across each capacitor is V. Now suppose I want to connect only a single capacitor, say C across this potential difference, or in place of these three capacitors, so whole of the potential will again be dropped over here, but now the total charge will be stored in only a single capacitor. So this will be now equal to CV. C, this V will cancel out, will be left by C is equals to C2 plus C. In this way, you can find out the total capacitance of the capacitor. As far as the numericals are concerned, you will take similar formulas as you have done for resistors, but you have to be very careful about the formula. Even after remembering, even after knowing, there is a chance of making a mistake. The common mistake which you generally make is, suppose I give you the value, say C1 is equals to 2 farad and C2 is equals to say 3 farad. I'll say find out the value in series and in parallel. See, the common mistake which you'll make is, when I'll talk in series, you'll just write down like this: C is equals to 1 upon C1 plus 1 upon C2. This is a common mistake which is generally made. What first mistake is that you simply just interchange it with the formula of resistor. That is another thing. But even if you remember the correct formula, then also this mistake is commonly made. Very, very commonly made. You just write C is equal, you have to be very careful in writing it as 1 upon C is equals to 1 upon C1 plus 1 upon C2. The second mistake you are going to make is, once you write over C here, then you'll find out the value, say 1 upon 2 plus 1 upon 3. That is going to give me 3 plus 2, that is 5 by 6. Usually the answer is written like 5 by 6, but it is the value of 1 by C. C will be 6 by 5. So these are the two common mistakes which I have told you, that you forget about the reversal of the value over here. You just write down C. Even if you have written the correct formula, here you can write down C is equal to 5 by 6. So you have to remember that this mistake is not to be made, and here also you have to write down 1 upon C. Check that you are using the correct expression. One more thing I would like to explain is, suppose the given capacitor is filled with a dielectric. So you have to multiply the value, that is, which you have already obtained, that is C is equal to epsilon naught A upon D by Q. But suppose the whole capacitor is not filled with the same dielectric. Then what will you do? I'll just give you two examples. Example 1. Suppose your capacitor is like this. And say this is half filled with a dielectric constant, material of dielectric constant, say K1, and half of it is say filled with a material of dielectric constant, say K2. It is half. Say this is D, then this will be D by 2. D by 2. Then what you are going to do? See, this is a sort of, this is a single capacitor, but it is behaving as if it is a series combination of these two capacitors separately. This is one capacitor, this is one capacitor. So this is a sort of series combination of two capacitors. Which two capacitors? One capacitor, say, since the area of plate is going to remain same, area A, distance D by 2, material dielectric constant K1. Here again D by 2, K by 2. These distances can be different also. You can have three also, separated into three partitions. Then it will be a combination of three capacitors in series. Three capacitors in series. So how you are going to do it? First, you will find out the capacitance of each capacitor separately. So like C1, will be now equal to K epsilon naught A d by 2. And what will be C2 equals to? K2 epsilon naught A upon d by 2. This distance can be changed according to if it is filled by 3 types of dielectric material or 4 or 2 or 1, something like that. And now you can find out as 1 upon C is equals to 1 upon C1 plus 1 upon C2. So this is a sort of series combination of two capacitors with different dielectric constant. It could have been the other way around. Suppose again you have got the similar capacitor of say area A, distance D. Then it may be half of it may be filled. Say upper half may be filled with a dielectric constant say K1. The lower half with say K2. Now in this case, this combination will be treated as if this capacitor and this capacitor are in parallel. This capacitor is separate. This capacitor is separate. They are connected in parallel to each other. If it is half filled, then now area of cross section of plate, area of plate will become A by 2. Distance will remain D only. So what we will do, we'll find out the capacitance separately first. Say C1 will be equal to epsilon naught A by 2 upon D K1. C2 will be equal to K2 epsilon naught A by 2 upon D, and you use the formula C is equals to C1 plus C2 for parallel combination. Simply add them up and find out the value. So this much you will do today. We'll try to do the numericals from 2.1 to 2.7 from your exercises. And then we'll go in for energy stored in a capacitor tomorrow. So this much work you have to revise. Keep on doing your solved example from NCERT book and the unsolved ones. Don't try to do all things together. So in steps, do the solved examples first and then do the unsolved ones as I am giving every day whenever it is required. Thank you.